It's time to build a cage that will contain all of the power of the motor. It's the motor cage. Today we are going to build the motor cage sub-assembly as shown on pages 13, 14 and 15 of the build manual. The motor cage is what houses the motor and batteries, and it protects them from any damage. We're also going to be fitting a couple of electrical components ready for when the wiring goes on the car. Lots to do, so over to our master builder Steve.
So the first items to actually mount onto our cage are two relays. The relay is essentially a switch powered by low current and allowing it to pass high current. So we need our bolt with a washer which goes through that tab, and then we take another washer and a nut to go behind the scenes and make sure I've got the right hole. We'll just get that one done up finger tight, and then same process for the second relay on the right hand side. And to tighten those up we just need a 10mm spanner and a socket in my case. No need to over tighten these, but we will tighten them up so they don't swing around as you can see it doing to start with. Now before I fully tighten this, what I'm going to do is actually point that in towards the centre a little bit. Little tip this is, for making your connections underneath, it's easier if you just point them in at maybe nearly 45 degrees. So I'm just going to tighten that one up at that point. There we go, and I'll repeat the same on the right hand relay. And again, bring that so it points in towards the middle of the car a little bit. So the next part to add into the back of our motor cage is on these two holes I've got my fingers pointing at, which is our fuse box. Take these two nuts that are supplied on the fuse box, which will only be finger tight when they arrive. We take those off, then find a little packet of fuses. Now this is a packet of 10 fuses, but you only need one. All the others are spares just in case. So if I get one of these, and a fuse is just a little strip of wire or metal plate that if too much current flows through there, it will burn out and actually break the circuit, and it's a good safety measure to have in your systems. So that slots over these two threaded pieces that come up, and we just need to pop the nuts on. No washers this time because these are flange nuts which effectively have a washer built in. So that's our fuse box, and this part here actually folds down and closes so that's sealed, and it latches shut with this little latch here. So now we need to fit that to the motor cage. The holes are a little bit tight on these sometimes, so I can just take my Allen key and wind those through to start with. And I'll do the other one and then I'll fit it to the cage. Whoop. Easy to drop things. And now these should fit through these two holes, if I get them lined up right. There we go, and then we have a nut to go on the back of each of those bolts or screws. I'm just going to use my Allen key to hold that in place, and I'm using my ratchet spanner at the back there. We do a little bit of tightening on each side, we can tighten things up evenly. Again, we're fitting plastic here, there's no need to tighten them too hard. There we go, so that's our fuse fitted. The next bit to add on to our motor cage is this connector block. So this is going to actually fit on the cage around here. But what I need to do is take one of my cable ties that was supplied with the wiring in your kit, bring it out through this top hole, and then through the top hole on the back of the connected lock, and then loop it back down to the next hole down, and then it goes back through this hole on the cage. And I will turn this round in a second so you can see what I'm doing at the other side, and put the tail of the cable tie through and pull it tight, and so we end up with that fitted there nice and tight, so I can snip off with my cutters here the excess of the tail. And then if I show you back here, we've now got this firmly attached to the back of the motor cage. The next item to fit is our isolator switch. It comes as two parts, the main body of the switch and this red key, which has a little peg sticking up here, and that goes into this slot here. So you push it in, and then a quarter turn clockwise and that's powered on, and a quarter turn anti-clockwise, that's powered off. Now it's important when fitting it to the motor cage to get this so it matches the off and on markings on here. So it's going to go in like that. So that's the off, and then that's the on. But what we need to do first is take that key out, and then we need to remove this rubber dust cover. So having taken those two pieces off, we take the switch around to the back of the motor cage panel, and then pop a washer on our bolt, and I'll pick up another washer and the nut to go on the other side, pop that through there, finger tighten that, and then the same for the other side of the switch. Now I've got that in place, I can tighten these up. So that's our switch in place, and what we want to check once we've actually put it in place is that the key switch goes in with the flange of the key to the off, and then when we rotate it, it points to the on, so that's the on position. Now I'm going to take that out, because whenever you're not actually driving the car or not wanting it to drive, it's best to keep that out. What you can do later maybe is actually attach it with some string or something so it stays with the car, but actually takes it out of the switch. I can pop my rubber dust cover back on here, and that should just stay on there because it's a stretchy rubber thing that is unlikely to fall off. And to keep my switch clean, just put that on there. In your kit you'll have a pack of wiring or cables, and every one of those will be labelled with one of these little markers. G2C and G2D are the two cables we've got here, and the connections on these are ring terminals. For these two connections on the back of the isolator switch, it's the large end that we need to apply. The small end surprisingly won't fit. So first thing we need to do is come under here and remove the nut, spring washer and flame washer on each terminal. I'm going to try and keep those in the same order so I can put them all back on in one go in a moment. It doesn't matter which cable goes on which terminal at this point, so don't worry about that. But what these cables will need to do is come out of the motor cage around here. So in terms of orientating, it's good to have the labels at the far end. I'm going to pop that on there. My flame washer goes back on, and my spring washer, and then my nut. And I'll wind that up finger tight for a moment, and I can adjust the position of the terminal at that point so it's leading the cable to come out in this little hole here. And I'll do the same with the other one. Just a case of tighten these up. And that leads our two cables coming out of this spot here. So now we've got all of our electrical components mounted on the back of our motor cage. Next important thing to put in is our motor, and here it is. But I wonder if Gav can tell us a bit more about electric motors.
Direct current. That's what the DC stands for in DC motor. Direct current is the type of power you get from a battery. When we connect the motor to the battery, the motor shaft spins. But what actually makes a motor spin? Well, let's start with the basic principles and work up from there. In front of me are some permanent magnets that have a north pole and a south pole. If I were to place the two north poles next to each other, you can see the magnets repel. But if I put north and south together, they attract. We can use the repel and attract forces to make something spin. Let me show you. I've fixed 2 permanent magnets to a dish and placed it on a makeshift bearing to allow it to rotate. Now using my other magnet, if I get the sequence just right, the dish spins. Notice how I need to keep alternating the magnet though in my hand. This is to make sure the attract and repel forces work together. If I stop alternating, the motor stops spinning. A real DC motor uses a mixture of permanent magnets and electromagnets. Now to show you what I'm talking about, I'm going to open up one of our green power motors and show you what's inside. Do not do that with one of your own motors. There's a really high chance of me breaking something here, and if you were to break your motor, your car wouldn't go anywhere, so do not do this to your motor. This one's not going to be used again, so I'm okay. Now, if I carefully take the core of the motor out, and you can see it's very stiff. Oh, whoa, look at all of those coils. So, those coils are made of copper. When you pass an electric current through a copper coil, it produces a magnetic field and becomes an electromagnet. Unlike a permanent magnet, you can turn an electromagnet off. And if you turn an electromagnet on and off in the right sequence, you get the same effect as when I was alternating the magnet on the dish. So how does our green power motor go about getting the same effect as me alternating the magnet? If you look carefully, you can see there's these copper plates, and in between the copper plates there's a gap. These copper plates connect to each individual copper coil. For each plate, there's a coil. The motor makes electrical contact through these brushes. When I put the 2 halves together, as you can see, line up with the copper pads, and they are what turn the motor on in the correct sequence. If we try to follow the copper plate that I've painted in red, currently the electromagnet would be turned off, but as it comes round and touches the brush, the electromagnet would now be on, making the coil repel the magnets. And then as it goes by again, it would be turned off, meaning that the forces can continue to work to make the motor spin. This little setup here is called a commutator and is used in pretty much every DC motor, or at least every motor I know of. Now, I said repel the permanent magnets, but where are the permanent magnets? Well, no need to worry. If I place this down carefully, if I lift up the casing, you'll hopefully see the big permanent magnets on the inside. And these are what repel against the electromagnets to make the motor spin. Really cool stuff. And what's even cooler is that we can simplify this down and build a simple little motor for ourselves. All you're going to need is some magnet wire, fine grit sandpaper, 2 jumbo metal paper clips, a neodymium magnet, marker pen, some tape, a D-size battery. Make sure it's a D-size battery, as smaller batteries won't have enough power to make this work, sticky tack, and scissors. And with all of this, you can make one of these. So, let's get started. Make sure bare metal is exposed on both ends of the paper clips. Mine had some paint on them, which I removed with a crafting knife. Always have adult supervision when using sharp objects. Bend the paper clips to make supports for the electromagnet. Tape the paper clips to each end of the battery, making sure the holes are aligned on the paper clip supports. I've used sticky tack to stop the battery from rolling around. To make the electromagnet, wrap the magnet wire around the marker 10 times to make a coil. Leave at least 30 mm of wire at each end. Cut the wire and carefully take the coil off the marker. Loop the ends of the wire around the coil to help it hold its shape. You may even want to add a knot to make sure it doesn't come loose. This bit's fiddly, so don't worry if it untangles, just loop it around the marker again. Cut excess wire by checking against the battery and check the coil spins freely. Make some adjustments if needed. Once happy, take the coil out. On one side of the coil, completely sand the insulation off of the wire. This will make continuous contact with the paperclip. Now to emulate a commutator. On the other side of the coil, whilst holding the coil vertically, remove the insulation from the top half of the wire. Do not remove the insulation from the bottom half. When the coil rotates, the sanded side, the shiny side, will make contact and form an electromagnet. As it continues to rotate, the insulated side will break the contact and allow the electromagnet to keep spinning. If using insulated copper wire, strip the insulation off of both ends and use a marker to insulate to get the same effect. Now, place the permanent magnet under where the coil will go, put the coil back through the paperclip supports, adjusting the shape again if needed, and hopefully, with a little push, it'll start to spin. You can even experiment with different coil shapes and see what else you can get to work. I could play with stuff like this for ages. Oh! We need to fit your motor into the motor cage. Let's go back to Steve.
Now, bear in mind the motor is pretty heavy, so you need to be careful when manoeuvring this and not to trap your fingers. Really good idea to have 2 people at least working on this. I've rigged it up with a bit of foam here so that I can actually stand this behind here. So the motor goes inside the cage and the holes in the foot plate, I'm hoping, if I get my alignment right, come through these slots here. So I've then got to take my motor mounting plate. I've already put my washers on my bolts. So that goes through there. In fact, what I'm going to do is I'm going to put my bolt all the way through my mounting plate and then through the hole in the foot plate of the motor. I'm going to put a second one through there as well. Hopefully I'll find the hole quickly. There we go. And whilst holding those 2 bolts in place, I have round the back here where I'm going to need them a washer and nut that I'm going to fit onto the bolts that I've got through there, and another washer and nut. Do those up finger tight, bottom bolts in. Now this is all loose, bear in mind, so it's moving around a lot. I'm going to just pick it up now and remove my bit of foam. Just drop that out the way. And now hopefully you can see that the way we tighten these bolts is by taking a ring spanner and putting it in through 2 holes at each end of the motor cage. I'm going to do the ones nearest me first. And I should get the ring spanner over the nut down there, and then I can tighten it. Now I've just knit those up to the point where that doesn't quite slide at the moment. And actually I'd forgotten one small part. It's this sprocket. Now you'll see the cutout in the centre of this isn't actually circular, it's what we call a D shape, so it's got a flat part here. And if you then look on the inside edge of this, you'll see that it has a little grub screw. Now it's important not to lose this grub screw. It requires a tiny little 2mm Allen key. So I'm going to wind it back so it's not sticking through, and I can check that by running my finger through there, and I can't feel the grub screw. I can feel the hole where it comes out but not the grub screw. So I can now take my Allen key out and lining up the flat on the sprocket with the flat on the output shaft of the motor, we can place that over there and slide it onto the motor shaft. Now as an approximation, I think you'll find that if you line up the edge of the outer edge of the sprocket with the side of the motor cage, it'll be about right for when we come to line up this sprocket with the axle sprocket. And to make sure it can't carry on sliding up and down, I'm going to just rotate that slightly and come down here, and I'm going to find that Allen key again, put my the grub screw rather, put my Allen key in there and just do it up gently, enough to stop it sliding, and that's ready for us to move on, and we'll go back and do the battery tray. So our battery tray is this item here. So it's a piece of folded aluminium that's been painted like the rest of the structure of the car. But to get this in, it is a little bit fiddly because the motor's kind of in the way, so we need to slide this end in towards the motor, and then the top end here, as I've got it, we need to flex down slightly, not bend it permanently, just flex it, and then it sits in there like that. And I'm going to get my first bolt in at the top here. Get it lined up. Not tightening it yet, so I've got all the bolts in. Tighten by hand as far as I can. And now I just need to tighten them with my socket and handle.
Once those bolts are tightened, you have finished the motor cage sub-assembly. Keep it safe until the chassis is fully built, and check back in with episode 1 to see what's next on the sub-assembly list. Or, if you've been following the build in order, we'll be fitting the motor cage to the chassis in the very next session. Now, this is where I awkwardly hand over to myself doing the outro. And that's the end of this video. If you need any further assistance with the Green Power project, please always feel free to email or call the office. We also have some brilliant community groups where teams share their experiences and expertise with each other. It's a wonderful place for collaboration, so don't miss out. All of the information you need is in the description down below. If you found this video helpful, please give it a like and maybe even a subscribe. Pretty please? Still, plenty of building left to be done, so I'll catch you on the next one.